Okay, we have started recording, and now practice quiz. Start with just A, and I kind of am figuring out how to have this not mess with my lettering and numbering, as if I put like a word or a pound sign in front of the numbers, and I call them AA and BB. And it doesn't auto number them and mess it all up for me. Alright, so just do part A. Let me give you a minute. Okay, 20 seconds more. Alright, so this one, I just do 2 plus 6 and I get 8. 1 plus 3 and I get 4. Divide 8 by 4 and I get 2. That's the correct answer. Part B. Does this problem seem to follow the correct order of operations? What happens first? Because there's addition that's going on and there's division. What happens first, addition or division? Let me give you a little bit of time to ponder that. 10 more seconds. Okay, so what happens first is addition. We added these two numbers. And we added these two numbers. The thing that we did the last was division. But this seems to violate the order of operations, because the more powerful operations come first, and division is more powerful than addition. It's, parentheses first, exponents, multiplication, division, and addition, subtraction. And so, why in the world does addition come before division? Well, there's a reason. The reason is whenever there's a long fraction bar, so there's more than one term, remember terms are separated by addition or subtraction, then there's an implied parentheses here, and implied parentheses here. The top and the bottom are really in parentheses, but they don't have to write them. It's just implied. So it's implied parentheses on top and bottom of fraction. All right. Well, let me give me a little feedback on part 1, A and B. Does this make total sense? Is it still confusing? So everybody could give me a little bit of feedback there. Oh, and when you give me feedback, you can go ahead and just hit enter as soon as you want. But the next ones, I'm going to have you, and from now on, I'm going to have you type your feedback, but not hit enter until I give you the signal, so that everybody gives me feedback at the same instant in the future. Now let me take a quick look at the feedback now. Okay. Makes sense with applied parentheses. Okay. All right, now let's go number 2. There's some very simple problems in part A, B, C, and then a question that you have to think about. And so go ahead and do those. So do A, B, C, and the question at the bottom. Meaning of 8 divided by 2, leave that blank for right now. Okay, 30 seconds more. Make sure you do this question at the bottom as well. When you divide 8 by a number, do you always get an answer smaller than 8? Alright, let me have you stop. 8 divided by 8 is 1. 8 divided by 4 is 2. 8 divided by 2 is 4. When you divide 8 by a number, do you always get an answer smaller than 8? It appears so. You always got something smaller than 8. But the answer is no. It's kind of a trick. Alright. The reason why the answer is no is, what if you divided 8 by 1? You would not get something smaller than 8. It stays the same size. When you divide 8 by a number that's bigger than 1, yes, you get an answer that's smaller than 8. But when you divide 8 by a number that's smaller than 1, we're going to figure out what this means in terms of this. Meaning of 8 divided by 2. When you're in elementary school, you get taught that 8 divided by 2 is like there's 8 cookies and 2 people, and how many cookies does each person get? And that's a great way to start it out in elementary school. But it doesn't help you when you get to problems like 8 divided by 1/2. You can't use that method anymore. We look in general at a question that's bigger than that so that we can use it to answer, even 8 divided by 1/2. And 8 divided by 2 means this. How many times larger is 8 than 2? Also, that's equivalent to this. This has the same meaning when you ask this question. How many 2's do you have to add together to get 8? Okay. So we'd answer these questions by how many times larger is 8 than 2? It's 4 times larger. How many 2's do you have to add together to get 8? There are 4 of these, so the answer is 4. Alright, now that's the way we're going to look at 8 divided by 1/2. 8 divided by 1/2, we'll ask both of these questions. How many times larger is 8 than 1/2? That can be hard to answer, but it's a little easier to answer. How many 1/2s do you add together to get 8? And you add 2 1/2s to get 1, and you have to do that 8 times, so that's going to be 16. Now, when you reciprocate this, remember the rule that you had for the homework today was 8 divided by 1/2 is 8 times, and you take copy dot flip. This one gets copied down, this one becomes a dot, this one flips over. Now when you flip it over, it's really how many 1/2s it took just to get to 1. And then you had to do this 8 times. So you get this. And that might give you a more intuitive answer So one of the reasons why this is no is when you divide by 1, it stays the same size. 1 is a dividing point. When you divide by numbers bigger than 1, you get something smaller than 8. When you divide 8 by something smaller than 1, you get something bigger than 8. Over here. Alright. So, for part 2, give me feedback on all of this. And the feedback I'd like is something like this. Already knew this, or this added insight. If you could give me one of those 2 responses. Already knew this, or this added insight, but don't hit enter yet. Just type it in. Okay, and if everybody will hit enter now, let's see. Okay. Alright, let's go down. Let's do part 3. Do A, B, C, and D. So those 4. Okay, 30 seconds more. All right, let me have you stop. This first one, I could think of it as temperatures. It was -3 degrees, went down 7 more, it's -10 degrees. This one, and this I think of as 2 separate terms. This one I think of it as all one term. Remember, terms are separated by addition or subtraction or an equal sign. And so in the same term, 2 negatives make a positive. So this is positive 21. This one, you make that plus, and you have to change the sign of the one afterwards. So it becomes 6. And this is 8 times copy dot flip 3/2. Now the shortcut for this is instead of getting 24 divided by 2, it's a little quicker to cancel first. The bigger the numbers are, the bigger the time savings this will be. And then you get 12 over 1, which is 12. Okay. Now, for these 4, I'm going to ask for feedback in one of 2 forms. Either nailed it or still working on it, and when you give me still working on it, add a little bit of detail. Still working on C, and so on. So type it in, but don't hit enter yet for feedback on these 4. And go ahead and hit enter, and let me see. Okay. Let's go back. All right. do E through I. So there's 5 of them to do. Thirty seconds more. Okay, let me have you stop. All right, before we go over these though, a couple general things. Is anyone using the Canvas app on their phone? And be willing to tell us a little bit about that. Anybody doing that? You can just use your microphone. Okay, so if nobody's using that, just want to make you aware of that. Did we already talk about this? Because I have 4 classes. I don't know if I've already mentioned this in this class.
No, you haven't mentioned it. This is the first time.
The first time? Okay. Advantages of putting the Canvas app on your phone, you might have a much easier time downloading. If you're having to have, take a picture with your phone and then transfer it to your laptop, you can avoid a step there. And you can also be getting notifications. So if I post an announcement or when I grade something, you can get an announcement, a notification of that, so you know exactly, For instance, I put an announcement up today. Hopefully, you're, as soon as you get into Canvas, you're either getting notified. Do you get notified when you get into Canvas if there was a recent announcement, or you just have to click on the announcements button to make sure to see if there was
I get email notifications.
You get an email notification? Okay, so that lets you know. All right, so that good. So that describes what's the announcement I just put up describes about the homework process, and that make sure you look at the graded homework, and you may have no grade on it, in which case you have to do something else. And you have 1 week in order to do that. Alright, so let's go to these EE now. Let me change color here. The 4th power does not apply to the negative sign. It only applies to the nearest thing because it's the most powerful. The negative sign is really the same as multiplying by -1, and that happens last. The most powerful thing happens first, so there's only 1 negative sign. And then there's 4 2's, -16. Negative divided by positive is negative. Copy, dot, flip. And then with the bigger numbers, if I multiplied these out and then had to try to find how do I simplify this, That's going to take a lot of time. But I don't have to do that. I can just divide this by 2 and this by 2. They don't have to be directly above each other. As long as one's on the top and one's on the bottom. Divide this by 3. Divide this by 3. And then I get 3 times 1 is 3. 8 times 5 is 40. Okay. Next one. The negative sign does get included because it's negative 3 multiplied by itself. It's the only way you'll get more than one negative sign if it's in parentheses. Over here, you only get one negative sign. This parenthesis means do me first. And I just want to point something out on this. Could also be done this way. So that's called distributing. And then notice we get exactly the same answer. Either way you did it would be fine. This one's a little quicker, but that's a possible option as well. Alright, now E through I. If you got them all right, tell me you nailed it. Otherwise, give me some details. Which ones are you still working on? Still working on it? H and I or whatever. And type it up, but don't hit enter yet. Alright, go ahead and hit enter. Comment that E was a little confusing, especially between E and H. That difference, yes. Alright. Now, letter J. Do those 3 parts. And let's have you just do those. And remove those parentheses. Actually, let me just have you do the top 2. The first 2 in letter J. Okay, 15 seconds more. Alright, so we distribute the 2 to both. It's the only way we can get rid of the parentheses here. If we could combine x and 1 together, we would. Kind of like 5 minus 1. But when one's a letter and the other's a number, there's no way. You just write it like this. Same thing over here. We're going to distribute the 5 to both. We're going to get 10y plus 20. Okay. Now do the next 2. Okay, 10 seconds more. Let me have you stop. All right, so we're going to distribute this one. And I'm going to get negative 21. Now, a very common student mistake is to put a negative here. But it's negative times another negative. Because remember, this could be called plus a negative 2x. So that subtraction sign makes this term negative. Now, negative times a negative makes positive 6x. So make sure your sign there is correct. And then the last one, we make fractions out of each of these. If it's not over 1, it's a whole number, not a fraction, we just put it over 1. Then we distribute the 2/3 to both. So when we distribute the 2/3 times 9x over 1 plus 2/3 times 12 over 1. Now, we can simplify first, or we can multiply to get 18 and then divide, or we can just reduce before multiplying. This becomes 6x, and then this becomes 8 over 1, which is 8 right here. All right, so give me feedback on these 4. Nailed it, or still working on it? And if still working on it, give me some details. You might also, like, even if you say nailed it, you could say, if it was meaningful review, you could still say, I needed the review, or, good review. And if not, just leave that off. Okay, so don't hit enter yet. Just type up your feedback. Okay, go ahead and hit enter. Okay, yeah, that last one, a lot of people are uncomfortable with fractions. And that's why we've got some fraction practice here. Let me put a couple more spaces in between these. All right. So, go ahead and do K, L, M, and N. Okay, 10 seconds more. Alright, now, I want to point out before we start that there are two terms, here and here. But on these other two, it's all one term. Remember, terms are separated by addition or subtraction. Okay. When there's more than one term, you have to get what we call common denominators. Alright, so we look at this and we think, what is the least common denominator? Between 3 and 6. The smallest number that they both divide evenly into is 6. So we're going to take 2/3 plus 1/6. We are going to multiply this one by 2 to get to be the correct denominator. If we multiply the bottom by 2, we have to multiply the top by 2. So it's 4/6 plus 1/6, which is 5/6. Okay, may have been a long time since you've done this kind of stuff. Alright, now that's in contrast. When it's one term, you don't have to get common denominators. You just multiply the tops, multiply the bottoms. If I did multiply the tops, I'd get 2/18. That reduces. Cannot leave your answer in unreduced form. Divide by 2 and you get 1/9. Now, we could have skipped this middle step and gone faster if, when it's all one term, you reduce first. And then 1/9. Would have gone a little quicker. And this one, the least common denominator, again, is 6. So 2/3 minus 1/6. We had to multiply this bottom number by 2 to get the right denominator. So this is 4/6 minus 1/6. 4 minus 1 is 3/6. And then we got to reduce that, divide by 3. We get 1/2. Last one, division. Again, it's all one term. Copy, dot, flip. Okay. And then reduce first if you want the shortcut. I always do that. And then 4/1 is 4. Okay. Give me feedback on this. Again, either nailed it or still working on it, and give me details of what you still need to work on. And you can mention whether, if it really was a helpful review, put that in there, even if you nailed it. Don't hit enter yet, just wait, let's get all the feedback at once. I know if I was a student in this class and I got it wrong and I saw all this feedback was everybody else was saying they got it right, I'd be feeling like, oh, maybe I should change my feedback. Okay, go ahead and hit enter. Okay, some comments about K and M. K and M, the ones that needed the common denominator. So, yeah, we hadn't really been doing any of those problems yet. All the fraction problems we've been doing so far were like L and N, where there were one term and we didn't have the common denominator. So it's brushing up on that. Alright, looks like we need some more review on this, so I can provide that in the future. Alright. And that's it for the practice quiz. So now it's time for questions on homework. Questions on any of the homework problems?
I have a question regarding on homework 1.4, and it's regard to problem 78.
78.
Yes,
Okay.
I believe it's the quotient of -4 and -12. Now, the previous problem, which was 77, I was able to get -3. However, when it came to 78, I was confused because I wasn't sure if it was the same answer as -3 or just 3 is by itself.
Ah, very good.
Yeah.
All right. My instinct on this would be to type. My first reaction would be -12 divided by -4, which would be 3. But that would be wrong. And you brought up the point. You looked at the previous problem. What's the quotient, and what the previous problem was the same question, but the order was reversed, and you got 3. So the real answer here is you have to keep these in the same order.
Oh.
The order is, remember, like some of them you change the order on. Like if it's something, subtract something, you don't change the order. But if it's one number, if it's 5 less than 8, you change the order and you put 8 minus 5. You know, there's different times, sometimes when you have to change order. This is not one of them. You have to keep it in this order. Now there's a couple ways you could do this once you write it in this order. One of the ways you can do it is realize that this division sign means the same as a fraction bar. And now we can just reduce the fraction. Negative of a negative is positive, divide by 4, and you get 1/3. Divide both of them by 4. Another way you could have done it, is you realize that this is anything is itself over 1. So then copy, dot, flip. And you'll come up with the same place.
Okay.
And it'll reduce down to 1/3. Either way you go about it, it's really easy. My instinct wants to turn it around and get a whole number, but this is first divided by the second when it says quotient.
Mm-hmm. Okay, gotcha. I was able to get it now. Thank you. That was very helpful.
You're very welcome. Good question. Any other questions?
Yeah, I had a question on number 83 and 84 on the same homework assignment 1.4.
Okay. All right. Let's start with 83. All right, screwed up some of this. Okay, so I'm going to go word by word. But in order to translate this word by word, I have to kind of realize how it's grouped. The quotient of this is one part of it. And quotient means the result after division. Then,
I don't see anything on your screen, but maybe it's just me.
Anybody else having that difficulty? Not
Yeah.
see-
It's
not-
flashing.
It's flashing, huh?
Over here.
Yeah, my screen is flashing in and out.
Whoa.
Huh.
Oh.
I'm not having that problem. This is Amalia.
So I only see a black screen.
On my end, it's fine.
Yeah, I'm fine too.
All right. I think sometimes there's just connectivity problems. I'm gonna, if it persists for another minute or so, close out Discord and then come back in to Discord. Hopefully that'll take care of it. Let me just swing over, get the size of this. In the main text channel, type in, if you're having visual problems. Let me see how many people are having that. Just put like visual problems if you're having it.
All right, I closed it and logged back in, and it seems to be fine now.
Okay, good. Good. Keeps going in and out. All right. Yeah, rebooting your computer would be kind of a later step, but try just getting in and out of Discord. Hopefully that takes care of it. And let me just quickly check my internet speed. I think I'm doing okay here. Alright. So we got negative 20 divided by 4. And of course, if you have difficulties on portions and miss part of today, you can go back to the video. I'll post it. It takes me usually a couple hours after class to get it all the way up. It takes a while to upload. Okay. It's decreased by 3. And so then this is going to become negative 5, because this is all one term, minus 3, which is negative 8. Okay. And 84.
Wait, can you go back to that?
Yeah.
How did you get negative 5?
Negative 20 divided by 4.
Oh, okay.
Negative divided by positive is negative, and 20 divided by 4 is the 5.
Okay, sorry, I missed that.
Okay? Now, you still want me to do 84?
Yeah, if
Okay.
you can.
84. Okay, so this one, I'm going to look at this way. Negative 4 is added to the quotient. This is all one big phrase together. The quotient of, which means the result after division. Now, these are two separate terms. This addition is the only thing that divides the two terms. That's a negative sign, not a separator, not a subtraction. Okay. So then this is negative 4 plus And this reduces to negative 3. And that total is negative 7. Does that answer your question?
Yeah, thanks.
And your name is?
Casey.
Casey. Okay, Casey. Any other questions?
I had a hard time on number 60. I know I'm kind of going back there, but
Okay. Number 60 in 1.4, right?
yes.
Okay. Let me type that in. All right, so I'm going to look in the numerator, and I see in the top there is 2 terms. That's how I analyze all this stuff. I figure out how many terms there are in the top, how many terms in the bottom. The bottom is all 1 term. So I can do something in each term. In the very first term that I circled, first thing that has happened is the exponent. Turn 5 squared into 25. In the next term that I circled, the first thing that has happened, the most powerful operation, the exponent, happens first. 2 to the third is 8. And then this term down here, I can go ahead and multiply that out if I want to. Negative 39. Alright, now when I get to here, I'm going to replace this with negative 50. I'll replace this with 24. So put these together and I get 26 over negative 39. Now, positive divided by negative is a negative. I like to put my negative out in front. But they could put the negative up in the top or in the bottom or out in front, as long as there's only one negative. And is there anything common between these two? Well, this one's even, this one's odd. But I think 13 goes into each one. It's a little bit hard to see at first. But divide this by 13. Divide this by 13. Oops. Okay. And then I'm going to get 2/3. That's going to be it.
Randolph, I had a question.
Yeah.
So if I did the negative 50 plus 24 and I got negative 26, is that wrong?
Oh, you are right. I am wrong. Thank you very much.
Oh, thank you. I had the same question.
Yeah, good. I'm so glad you pointed it out. Negative 26. And then negative over by negative makes positive 2/3. That's my answer. And that plus sign at the end is optional. Thank you for catching me. All right. Any other questions?
Thank you. That was really helpful.
On 1.3, I had a question for 53. It's negative 8 parenthesis 1/2 parenthesis.
Okay, you said it was 1.353? Yeah.
Yeah.
All right. 53 and 1.3. 3. And the problem is negative 8 times 1/2. And what we do is we turn them both into fractions. And the negative times a positive, the whole thing is going to be negative. And you can just multiply the tops together, multiply the bottoms. How come we don't need a common denominator? We're going to get more into that a little bit later. But when it's all one term, you don't need to. Multiplying or dividing fractions, you just multiply the tops, multiply the bottoms. But then you have to reduce 8 divided by 2 is 4. Okay, does that take care of, does that answer your question?
Yeah, thanks.
You're welcome. Sometimes I do with a problem, but there's still a leftover question, and I want to make sure that everybody's understanding. Any more questions? All right. Well, it's break time, so we will start again. At 1:37 p.m. And yeah, sometimes I remember a previous semester, one day a number of people had connectivity problems, and then my wife at her work, when she got home, she was telling me, oh, I had connectivity problems too. And it's like sometimes there's just disturbances, I'm not sure, in areas. But hopefully everything's back good when we get back at 1:37. If anybody's got a quick question or needs to talk to me individually, you can right now, or I'm going to mute and take a break myself. All right, let's get started again. We're going to do two sections again today. The first section is 1.5 properties of real numbers. Number one, the distributive property of multiplication over addition or subtraction, and ask you to do a problem. 2 times 3 times 4, and so that's A and that's B. So what I want you to do is work individually on these problems and go to your group chat, and when I give you the signal, you'll have, so I want you to type in your answer for A, put A, and then give your answer, put B, give your answer, but don't hit enter until I give you the signal. And group leaders, make sure you know who is the spokesman for the day for today. Let me see how many groups we got. 5 groups. Okay, 30 seconds more. Okay, go ahead and hit enter, and let me give you a little time in case you have different answers to discuss it and see which answer you think is right. If there's 2 different answers, you can state your case. All right, let me have you stop. Group 3, what did you get for A?
Hi, my name is Freddie Lopez. What we got for A is 24.
Okay, did you do it this way? Like that?
Yes,
Okay.
just like that.
Okay, what did you get for B?
We have gotten 48.
And did you do it like this?
Yes, just like that.
Okay, so let's go on. Now, true or false, circle one or the other, or state true or state false for that one. Let me give you a quick 30 seconds. Enter that, your T or F, in your text, but don't hit enter yet for your group. Okay, go ahead and hit enter. And make sure everybody understands. Yes. Okay, group 1, true or false? Let's go to group 2. True or false?
This is Amalia. We have I go with true and somebody else put false.
Okay, and can you explain any of the reasoning?
I say true because if you distribute,
This one?
uh-huh, uh, then it'll make it true.
Ah, if you distribute, it would make it true, and then we would get 48 on both sides. So the big question is, do you distribute this? So that's an alternate way to have done this one. If you distributed, and that's actually what happened over here, because you multiplied the 2 times the 3. Oops, shouldn't have been 12. Let me fix this. If you multiplied the 2 times the 3, you'd get this, and then distribute it, and you'd get this. So this really is the distributed part of this. So the big question is, since we get different answers, both of these techniques cannot be correct. Which one is true and which one is false? And it turns out this one is false. We have to do it this way because parentheses means do me first. So it has to mean this and then times 2. But you might ask, well, hold on. I thought you could use the distributive property. Well, let's look at the distributive property, its full name. The distributive property of multiplication, this is multiplication, but it goes over addition or subtraction. And this is not going over, there's no addition or subtraction inside here. And it turns out you cannot use the distributive property in this case. It's only when it goes over addition or subtraction. We get 2 different answers, and this one is false. All right, let's go to number 2. Now I'm going to ask you to do all 3 parts at once. And then as you get your answers, you type them in for your group. But don't hit enter yet. I'll give you the cue of when to hit enter. Go ahead and hit enter. Give you a moment to look at everybody else's. Let me check again. How many groups do we have? 5. Okay. So group 5, what do you have? Anybody at group 5? Let's move over to group 4. Group 4, what do you got?
This is Randolph. We got 14 for A.
Okay, how'd you get the 14? Was it like this?
It was with the distribution, so I did 2 times 3 is 6, and then 2 times 4 is 8. And then I got
it like this. So there's two different ways you could do it. Either way, you come up with 14. Okay, and on B, what'd you get?
I got 14 as well.
And so C is
True.
true. Now, we'll notice the difference. The name of the distributive property of multiplication, it has to go over an addition or subtraction sign. Now, when we looped it over the top, 2 times the 3, but the next one went over an addition sign. That's why you get the same answer each way you do it here. And that's why this is true. This one, you didn't go over addition or subtraction. You went over a multiplication. There is no distributive property of multiplication over multiplication. It's just over an addition or subtraction. Okay. And number 3, on which expression can you use the distributive property? Well, this one, it's no. Because you'd have to distribute it over multiplication. On this one, it's yes. Because you distribute it over addition. And the data backs us up. When we try to do it over this one, we get a false statement. When we try to do it over this one, we get two things that turn out to be true. When there's a property like this, we can check out the property and verify that it really does work. All right. Now, number 4. Give an example of the distributive property. So everybody on this one, do something on your own, but don't hit enter yet. And then give both sides. So you're going to write an expression, it's going to have parentheses in it on the left. And then equal sign, and then on the right, it won't have parentheses. So make up your own example of the distributive property. And go ahead and enter and look at the different examples. Okay. All right, so if I made up an example, well, let me go to group 2. What example, can you give me an example?
Yes, this is Amalia. 3 parentheses 9 plus 1.
Okay. And so then this could be then 27 plus 3 if you distributed it to both. And it's the same answer as if we did just 9 plus 1, got 10, 10 times 3 is 30. There we go. Okay, and notice, and I did it both ways here. When we commonly refer to it, oftentimes we don't like to write the whole name of this property. But this is the whole name. We often just say, give an example of the distributive property. But we really should be saying the distributive property of multiplication over addition or subtraction. But even the textbooks will shorten it. Math doesn't like to say more than it has to. It just gets used to the idea that this is shortcut for all of this. But the first bunch of times you refer to it, you probably should refer to it as whole, the entire name, so you really understand it. All right, so do number 5 and number 6. Give everybody a minute. 30 seconds more. Okay, I'm going to do these. Does everybody agree with my answer? Anybody disagree? Okay, let me do this one. Does anybody disagree with my answer here?
Isn't it just 6xy or
That
no?
is correct. This, I'm making the classic mistake of distributing over, but not over addition or subtraction. So that's not correct. It would have to be just this. There's no distributing. You just get rid of the parentheses and then you can just multiply, and you can rearrange the order and multiply the 2 and the 3 together. And that's it. Alright. Alright. I'm going to have you do these first bunch of problems. Simplify each of the following, but I'm going to give you a short amount of time here because I've got a fair amount to get through today. Okay, give you 30 seconds more. Just get as far as you can. If you can't get them all, that's fine. Alright, let's go to this first one. We distribute. When we distribute this next one, negative 4q, it's minus and a minus. It's plus 28. Let me kind of show you another way I could have done this. Subtraction is the same as adding a negative. It might be a little more clear this way. Negative times negative is positive. And when we distribute the negative sign, it's got to go to both terms. Common student mistake is to add these two together, but that's an error. What the problem with that is that 9 is being multiplied by this, and so multiplication has to come before addition. But what's even easier to see is terms. That addition separates. That's one term, this is a different term. So we're going to distribute this, leave the 5 there. 9 times 6 is 54. So then this becomes 9n minus negative 54 plus 5 is minus 49. Okay, and we're going to do this one. And I got to distribute this first. Then these two, what we call like terms. We get like this. All right, now that's all I wanted to do from that set. And we're going to go to, I'll usually have a few more problems than I can actually get to on one of these things. Sometimes I have kind of wishful thinking, like, if it goes really fast, maybe I'll be able to get to these. All right, 1.6, the next section, simplifying expressions. Our goal is to be able to combine 2x and 3x, add them together, and understand why. All right, so we'll start with this first one. And let me just have you do the first two problems. True or false for both number 1 and number 2. And go ahead and type up your answers in your group, but don't hit enter yet. So do 1 period and then give your answer, 2 period, give your answer. I'll give you the cue when to hit enter. Ten seconds left. Go ahead and hit enter. And number 1 is true. Number 2 is false, because 16 plus 3 is now 21. All right, now there's something else you got to do on this next one. Kind of take notice of the blue numbers, but then forget about them for a moment, and go ahead and figure out number 3, whether that's true or false. And enter that into your group chat, T or F. Then do number 4. Enter that into your group chat, T or F. And number 5, enter that into your group chat, true or false. Okay, and hit enter and look at your different responses. And group 5, what do you have for number 3?
I got some different answers, but let's see, what did I put? I got false for number 3.
Okay, well, let's check it out. 3 times 2 is, what, 6?
Wait, nope, I realize I'm wrong, it's true.
Alright, and then this one is 8, and this one is 14, and 6 plus 8 is 14, so that's true. Alright, how about number 4? What do you have for 4?
True.
6, plus 15 and 21. Did you wind up getting true for number 4? Because it
Yes.
looks true for me, yeah. So you agreed with that one. And how about number 5?
Number. Back and forth here. That's false.
6 plus 15 and 7 times 9. 7 times 9 is 63, way bigger than this one. So it's not true, not equal, so this one is false. Alright, now, before you do the next one, I'm going to prime the pump here. 3x plus 2x. If I had to add these two together, makes sense to me to add the 3 and the 2. But then I don't think I want to leave just x as just x. I think 3x plus 2x, I should add the 3 and the 2 together, but just putting the x as x doesn't make sense to me, so I'm going to put x squared. So 3x plus 2x, that up arrow means squared. So this would be 3x plus 2x. I'm going to say that that's 5x squared. So in your chat group, type T if you agree with me. Type F if you don't agree and you think this is false. And then look at the majority of the responses. So go ahead and hit enter on that. Look at the majority. And let me go to group 3. What's the majority of people saying? True or false? For number 6. Pardon?
The overwhelming consensus for 6 is true.
True. It looks like it's true. Doesn't it feel true?
Certainly it does.
Yeah, because 3 and the 2 make 5, x and the x makes x squared. Is there anybody who disagrees, though?
Seems like it would be false to me, but I'm not entirely sure.
Me too.
We've got more people, a couple people saying it seems false. Now, if it seems false, let me erase some of this extra stuff so we can see this kind of clearly. Alright. And this was true over here. What I want you to notice is look at the stuff in blue now. On the 2 over here, 3 times 2, and then plus 4 times 2. But notice the 2 stayed the same, and the 2 is kind of playing a similar role as this x over here. Because that stays the same as that. And then we wound up adding the 3 and the 4 to get 7, but the 2 did not become 2 squared, it just stayed 2. And this was true. And look at over here. Look at the ones in blue. They're kind of like the coefficients of this. And 3, 3, 3 is kind of like the x, x, x. And 2 times 3 plus 5 times 3, we added the 2 and the 5 and got 7, but the 3 and the 3 didn't combine, they just stayed as 3. And although that seems strange, it worked out to be true. Now, when we did just what's occurring in number 6, look at the blues. Those 2 plus 5 adds 7. It's like the 3 plus the 2 is 5. The 3 and the 3, well, it makes sense to add the 2 and the 5 to get 7. The 3 and the 3 doesn't make sense to just write the 3 once. So I'm going to put a squared on it. But when we do that, we get something false. So this one is false. It's following the pattern of number 5. It's not following the pattern of numbers 3 and 4. All right, now this one is a pretty abstract concept that we were talking about. Give me some feedback. Does this make sense? Or do you need more explanation? Do I need to review it some more? Or is this making some sense right here? If everybody give me a little feedback. Okay. So at least one doesn't understand. We can go over a little bit more. Okay. Let's come back. All right, so this one is really following the pattern of 5, and so it's one of the reasons why it's false. So how does this compare with problems 3 and 4? It's not the same. We're not doing the same thing, because if we were following the pattern of 3 and 4, we'd have left this as x and we wouldn't have put the squared. Alright, now, what we wind up doing in math is something that feels very awkward and non-intuitive. Is we wind up taking the real answer here is 3x plus 2x. You add the numbers, but you don't do anything with these. You just write it as x. You don't make it x squared. You just make it 5x. That's the real answer. Now, why do we do something so counterintuitive? Well, you might change your intuition when we realize what's going on here. Create a problem where you take 3 of something and add 2 of something, you get 5 of that something, where the something is an apple. 2 apples plus 3 apples. Do we write 5 apples squared, or do we just write 5 apples? Notice we're just adding these two, and we're not combining the apples. We're just saying 5 apples. The letter y is going to be the same way. 2 y's plus 3 y's. We just add the numbers up front. We call those coefficients. And then y and y, we just say there's 5 of these y's. Now, let's do it again with the number 10. 2 times 10 plus 3 times 10. By the way, 2 times 10 really means add 10 to itself twice. 3 times 10 means add 10 to itself 3 times. And then, how many 10s are there altogether? 5 times 10. The answer is 50, not 5 times 10 squared. That would be 500. Okay. And then, the number 4. 2 times 4 plus 3 times 4. Let's just do it the abstract way. You just add the numbers out in front. 5 times 4. And then we would get 20. But this also checks out. 8 plus 12 is 20. The letter x. 2x plus 3x is 5x. Now, 2x really means x plus x. 3x really does mean, add this together 3 times. And then there are 5 of them. 5x. The unit feet. If I saw 3 feet plus 2 feet, would I say 5 square feet? Nope. I would just say 5 feet. Okay, and then expand 5 times 4. means to add 5 4 times. To expand 3 times 5 means 5 added to itself 3 times. Oops. 8 times 2. You could do it in either way. 8 2 times, or 2 8 times. Doesn't matter. Either way, you're going to come up with 16, the same thing. And y 4 times, w 3 times, and so we're just adding the coefficient. There's an unwritten 1 before each of these. You add them together, but you don't get w cubed, you just get w 1 time. Okay, and then condensing. I would condense this as 9 4 times. This is 1 2 3 4 5 x 5 times. 3 2 times. R squared 1 2 3 times. It's like, they're called like terms if they have the same variable to the same power. That's the up arrow means raised to the power. So, so this is contradicted. If you expanded this out, you'd get x squared added to itself 5 times, not 5 x's. Alright, so we went a minute over time. The homework. Let me state the homework. Is the 2 sections we did, 1.5 and 1.6. And groups 1 and 4, will you hang on for a minute and let me talk to you two, and the rest we're done. And let me go in here. Sometimes groups get too small or have some other difficulties. And how's it going with both of your groups? Because there was a time when you didn't respond, both of you, today. I'm just wondering what's up.
I think that we're okay. Are you sure it wasn't group 5 that didn't respond?
So it's group 5. Okay. Group 5 and group 1. Can you all tell me how it's going?
This is Casey from group 5. We've been responding, but I know our group leader's microphone isn't working.
Ah, that's the issue today. Gotcha. Okay. All right. And everything else is going okay in group 5? There's enough people and so on?
Yeah, it seems like everyone's engaging.
Okay, very good. Group
Can
1.
you guys hear me now?
Yes, I can hear you now.
Oh, okay. I think my microphone was turned on the app Discord, but I think my microphone was turned off on my computer in general, and I didn't know it was turned off, but I fixed it now.
Okay, great. And group 1, how's it going? Anybody here from group 1? So maybe nobody's here. It looks like Jamie was here. Maybe there was only one person in group 1.
I think, because I saw a message in the general board, and I believe Jamie said something along the lines of that she had to go leave someone early because she had to pick up her brother or something along the lines of that.
Okay, great.
Yeah.
Thanks for letting me know.
You're welcome.
And let me check in with group 1. I'm going to type a message to them, and they might be too small of a group, and if so, I can move them and assimilate them into another group. Okay. All right. I will see you, the rest of you, on Wednesday. Anybody have any questions?
Have you stopped recording?
I have not. Thank you.
You're welcome.